Hi, everybody. I'm Harold, and I'm from Singapore. This is going to be a little bit of a weird talk for me. First off, I have no slides. Well, actually, one slide. That's that slide. That's it. Okay. I've heard that it's possible to give talks without slides. Imagine that. And so I'm going to give it a go today, and let's see how it goes. The reason why I only have one slide is because, unlike the usual case where I'm telling you about things I have done, I'm going to talk about stuff I have not done. I want to do it, and I would love to get your comments about what I want to do. Okay? So let's give this a go. Now, the work in my lab can be roughly split into three broad areas. The first is tactile perception for physical intelligence, the topic, not the company. Robot learning, particularly imitation learning, more recently with diffusion models and trustworthy aspects of that. And finally, this last part, which is what I want to focus on, which is on social intelligence. Okay? And previously, we've been working on models of trust for human-robot collaboration. Now, I've been seeing, and I bet you've been seeing, all this work on foundation models and other topics. So, for example, like computer vision, but also for navigation and grasping and manipulation. And I was thinking, well, can we have a foundation model for HRI? But as Katsu was just saying, HRI is a very broad, complex topic. So what does it even mean to have a foundation model for HRI? What would a model like that look like? What would it do? Who would use it, and for what? So let's make sure we're on the same page first. What is a foundation model? People have different interpretations of this, but let's use my interpretation, which is that it's a strong prior. Okay? It's a strong prior that manifests as a model, typically a machine learning model that's been trained on large amounts of data, that then you can use zero shot, so out of the box for a particular task, or you can fine-tune it with a little bit of data to get better performance. Okay? So that's my take on what a foundation model is. And I think a foundation model for HRI should basically enable interaction. It should enable interaction with people. That's what we want from this model. Okay? And that's still rather vague. So let's try to ground it. My wife, over there, a little bit dark, but that's my wife, Hazel, and I just celebrated our 10th anniversary 2 weeks ago. Okay? And it's been a great 10 years. But like every marriage, there's ups and downs with family. And so one of the challenges we faced was this with my son, Aaron, who's also there, when my daughter was born. Okay? He found it challenging, and so he was acting out a lot. And we tried to reason with him and say, son, we love you just as much as your sister. That did not work, okay? What changed for us was when a good friend sat my wife down, and she said, here's Hazel. Look, imagine if one day Harold came back with a young, new wife. How would that make you feel? Imagine if you then say, I love you just as much, I love you just the same. Would that change how you feel? And the point is that it will not, right? It doesn't change how you feel. And that analogy really clicked for us. The gift that our friend gave us was a good mental representation of Aaron, so that we could understand him better, so that we could change our behavior to better support how he was feeling. So I want to give this gift to robots, okay? Studies in cognitive science and in psychology have shown that humans have very rich mental representations of other agents, and that enables us to predict their behavior and interact with them fluently. And these facets of these representations have names, and we use them every day. We call them goals, intentions, beliefs, desires, fears, emotions. Now, for robots to have this capability means that they need to take information from their sensors, images, let's say, from the cameras, and then construct representations of agents that are informative of their future behavior. All right? And to me, that's exactly the place we should start for a foundation model for HRI. So notice here that I'm not talking about a full-fledged GPT model. I'm talking something more like a CLIP model. So if you don't know CLIP is contrastive language image pre-training. It's a building block for a lot of bigger models, okay? It learns joint representations from text and images, okay, using contrastive loss, hence the name, okay? I propose that we call our model HIP over there, okay, HIP because it sounds hip, and also it stands for Human Interaction Pre-Training, right? Stealing the idea from CLIP. The idea is that HIP would encode raw signals from our robots, say visual frames and language, to some joint representation that is predictive of agent behavior. That's how we're going to train these things, okay? We want the representations to encode information that when combined with some additional context, say the environmental context, this enables the prediction of what the agent would do. So what can you do with a HIP representation? If you're a machine learning person, well, you could use it as a component in your robot learning system so that you don't have to learn from scratch, okay? We saw some of those learning systems just now. Imagine if you don't have to pre-train parts of that, of your intention predictor. You could use one out of the box, or you could fine-tune it with little amounts of data and get it working for your domain. If you're a planning person, you could use it to ground your symbols. If you are a systems person, you could combine it with memory. So imagine this. If you use our model, the HIP model, you could get an agent representation that is located in some space and time. You put it in your memory. And then when you interact with that agent again, you can draw from this repository of memories and experiences with that agent in order to decide what to do. And that's, to me, rich interaction. So how do we get HIP? Well, HIP is fundamentally a machine learning model. So how do you train a machine learning model? There are three basic ingredients: data, model, loss, right? This is from any Machine Learning 101 Intro to Machine Learning class. So let's walk through our data, our model, and our loss. So for data, I can think of three candidates for data, and most likely we're going to have to use all three. The first is synthetic data. So we can get data from the decades of research into psychology, human factors, and cognitive science. There's even a data set called the agent data set, but these tend to be fairly simplified. Artificial domains with artificial agents. So for example, in the agent data set, the agents are these small little circles or cubes, and they move around. That's not hyper-realistic. What we want to do is to make sure that we can use these models in real-world situations. The second data source is the vast internet, YouTube. We could get videos. The problem with that is noise. There's huge amounts of noise, noisy videos that maybe are not accurate of human behavior and human latent states. And we need to annotate these videos. Again, maybe LLMs can help us here. So VLMs can do some parts of these annotations. Also, we've shown in the past that actually, if you use an LLM, LLMs can do some zero-shot prediction of human intent and be a zero-shot model already initially. The final data source, of course, is data collection. We can collect data. We are actually doing some experiments on that in the domain of social navigation. And Sonia was bringing that up earlier. I think that's really nice. I think social navigation, where robots are navigating in human environments among people, is the right amount of complexity. Okay? The behavior is relatively simple, yet it's a very rich setting. You have multiple agents, you have social norms, you have safety constraints. So I think this is an exciting time for us, and we're collaborating with several people here in collecting this data from multiple places around the world. And stay tuned, we'll have something about that in a few months. So let's move on to model and loss, and let's just take them together. So you could train an end-to-end model, like a transformer, let's say. But I have a slant or a bias towards structured latent variable models. Okay? These are models that have encoders and decoders. You can imagine an encoder that takes in some raw signal and encodes into some latent space. Okay? And this is your representation that you want. And typically we want dynamics, so this latent representation will evolve over time. Okay? Now, why might you want this? Because you can combine this with a form of self-supervised learning. You can use the current prediction latent state to predict future states. And this is what we want from our models, because we want them to be able to predict future behavior. And we're not the first ones to think about this. People who are working on intuitive physics, they've tried this out already. So there's a paper recently from Meta showing you can learn intuitive physics using these kinds of models and these kind of self-supervised learning techniques. I think we want to go a little bit further. We want to think about the fact that we can imagine agents having different beliefs or different intents of different goals. This hints at a compositional flavor to these representations. I think we can try to learn these kind of disentangled compositional representations using the right kind of regularization as well as auxiliary losses. So that's basically how we're going to get there, partially. This is a rough sketch. We also need to think about evaluation. Evaluation is critical, and at the end, the proof is going to be in the pudding. So we're going to see how effective HIP is for downstream tasks, how easy it is to integrate into your particular application, but also how effective it might be, how good it is at predicting human behavior and their latent states. So one task may be social navigation, but I hope that you can tell me what task interests you as well. So for all of this, I need your help. This is not something that I think I can do on my own. I think there's a lot of work that needs to go into the data set creation, getting the annotations just right, collecting the data. And so my email is right there. Okay, that's my website. Feel free to get in touch. Come talk to me. I'll be around for ICRA the whole time. If you're interested in HIP, then yes, let's get in touch. Okay, thank you.
Thank you. Any questions, suggestions, comments?
Yeah, so we hear lots of attempts at building foundation models for domain-specific foundation models. And I'm just wondering how much mileage we can get by just leveraging the considerable natural language capability of the LLMs, like ChatGPT, They are general purpose LLMs, because you can you can have a pretty good, deep conversation, technical conversation, as we are all having around here, in natural language, and very good ideas can be generated, good intuitions can be conveyed. A lot of papers are all in English, So can we just stay with vanilla ChatGPT and get how much mileage can we get in specific domains like human, robotic interaction?
So that's a great question. So we had a paper a couple years ago in IROS, and this was not ChatGPT, the recent one. We did this early, so this was GPT 3.5. And we found that GPT 3.5 can be pretty good as a human model to predict what human beings believe and feel from language tokens, okay? There are caveats, okay? What is the caveats? Number one, it's very sensitive to prompt structure. So if you get the prompts wrong, you get garbage sometimes. Two, more importantly, they're not grounded. So you're getting everything in terms of text tokens. And sometimes things that happen in the environment, we talked about robotics here, that matter. Little nuances in gestures, in how you look, the way you look. My wife, for example, can get me very scared without even saying anything. She just needs to look at me. And I'm not sure that ChatGPT captures all of that right now. I think there still needs to be work done into capturing these things. Yeah, we can leverage them, but not fully. Yeah. There are gaps.
Thanks a lot.
Mm-hmm. Hi. I think the format of the talk works. I have some questions and some stuff I would like to clarify with you. So in your how you imagine a HIP, right, is a model that can model and reason over the theory of mind of people that robot can interact with, correct? And as you mentioned before, current LLMs have some sort of representation of the theory of mind, or at least they can solve some theory of mind problems. Mm-hmm. And then when you go to the data collection, or data, for example, YouTube, right, we can make a model, watch a lot of Friends, and then check whether they can reason over Rachel knows that Ross knows, etc., right? Or rather, LLMs can do that. LLMs have demonstrated that they can do that. But how would we extract that kind of information from just watching the videos of Friends? Because LLMs, I assume, have read the synopsis, and that's how where they can leveraging those understandings of the dynamics between the humans. But that's not necessarily what happens when we give them raw images or raw video, isn't it? Mm-hmm. Maybe I'm wrong. Please correct me if I'm wrong.
No, you're absolutely right. So that's why I said that to use the videos, that comes with annotation overhead. We need to annotate them appropriately. So I think what we've learned from training lots of foundation models is not necessarily, quantity is not necessarily the main determining factor of how good your foundation model is going to be. It's going to be the quality of your data set as well as diversity in it. And we need to pay attention to those things when we're creating our data set for training.
Great. So then, sorry, one more follow-up. I'll catch you later.
Yeah,
Oh, hold on, I
please do
think-
that. Okay,
Yeah.
thank you so much, Harold.
Thank you, everyone.